And welcome back as we continue to explore astronomy. Let's go ahead and segue a little bit by talking about the laws of nature and how they will apply to our study here. So the first thing we need to have an understanding of when we start talking about the laws of nature is scientific law. Now, scientists have worked very hard to extract various scientific laws from countless observations, hypotheses, and experiments. Now, these laws are really, if you want to think about, as the rules of nature. Now, the remarkable discovery about nature, as scientists have done all these observations, hypotheses, and experiments, is that they've found that the same laws apply everywhere in the universe. These rules determine that the motion of stars is dictated by the same rules and laws that would determine things such as the arc of a baseball after a batter has hit it out of the park. It's the exact same thing. These things are applicable whether you're on Earth or you're far away on a planet, let's say in Alpha Centauri. And the reason why we can talk about this in the way we do is because this concept of universal laws. Without the existence of universal laws, we could not really learn astronomy very effectively. Because if you think about it, if each pocket of the universe had different rules, we'd have very little chance of interpreting what happens elsewhere. If what happened on Earth was different than what happened on Venus, and we had totally different rules for physics and chemistry and stuff like that, we wouldn't be able to derive a consistent rule. This consistency of the laws of nature permits us to understand those distant objects without requiring us to travel to them and then learning whatever local laws dictate things there. And by having a consistent set of laws, this also allows us to apply what we learn or practice from our point of observation here on Earth to the greater universe at large. Now, naturally, of course, if we have created something, we occasionally do need to come back and update it, especially when we're talking about theories versus laws. Laws are steadfast things. They're not going to change. But theories are things that are based upon what we know from our hypotheses and data. So this is going back to this idea of having scientific models. And with scientific models, remember, we're constantly testing them. It's part of that peer review process. And because we're constantly testing them, those models can change. New experiments and observations can lead to new and more sophisticated models that include new phenomena and laws about those behaviors. For example, if we want to pull something, and we can talk about the general theory of relativity proposed by Albert Einstein. This allowed us to predict and eventually to observe a strange new class of objects that we hadn't really known about before, which we would now refer to as black holes. Now, this kind of patient process that we have to go through of observing nature very carefully and very precisely allows us to demonstrate the validity of new scientific models. Now, there is one thing for us to keep in mind as we start looking at all these different pieces moving forward, and that is the limitation of language. One very important problem that we have to understand when we're describing scientific models has to do with the limitations of the language we use. Often models, and when we actually look at scientific models, they're described instead not with regular language like you and I might speak, but instead they use complex mathematics, they use equations, formulas, stuff like that. Now, for our purposes, we're going to kind of avoid some of that complex math, as for us to really have a deeper understanding of that would require us to have a good, precise language and understanding of mathematics. So we're not going to worry about how to do all the different model pieces here. Instead, we're just going to kind of do the best we can using the limitations of language. Now, when we try to describe complex phenomena in everyday terms, one thing we will encounter is that the words themselves may not be adequate to do the job. For example, you might have heard of the analogy, a very inaccurate one, of how the structure of an atom has been likened to a mini solar system. We've seen different models, for example, of that. And it kind of, it looks like the nucleus of the atom kind of looks like the sun, and then you have the electrons floating around, kind of like little planets. This is not correct, obviously. Again, it's a limitation of the language and the visual representations that we can give versus the mathematical models which more accurately describe the behavior. And while some aspects of our modern model of the atom do actually remind us of things like planetary orbits, the many other aspects of its actual properties are very fundamentally different. like you have all the different orbital shells and stuff like that that go in, and you have the fact that electrons can, change certain behaviors and stuff like that. We're not going to go into all those different complexities here, but just know that, again, this is something that is limited by language, that a model through mathematics and different equations, stuff like that we could actually prove that these things are the way they are not possible in our normal everyday speech.